Good afternoon, guys. Today I'm going to explain about solar photovoltaic system. And before going to the solar, I'm going to introduce something about solar photovoltaic. This solar PV is used to convert sunlight into electricity, and these are made from semiconductor materials like we are showing here figure photovoltaic single line diagram. Here they are using some devices like single crystalline and homo junctions and polycrystalline thin films and multi junction cells are there. And coming to the electrons that are knocked loose to flow through the material to produce an electric current is known as direct current, like we have to call as DC current. In short, the light separates electron from atoms to create an electric current. In physics, this effect is also we have to know known as photovoltaic effect. The direct current generated can be converted into an electrical current with the help of special tools called inverters. These solar PV plant are designated from similar generator objectives of two main functions. One is PV solar plant and another is do not concentrate on energies. Different components we are using in the solar. Now we are going to different models of solar. First one is single diode model, and this is the single diode single diode model of ideal photo cell, and this is the equation of this ideal current. And here IFS means photo current and ID is short circuit current. For this ideal diode, I'm giving some solar Simulink model. This is the Simulink model. What we have to given here is iphase and id, and it going to 7.68 and voltage is 26.43. We are taking here one parameters of kc 2000 solar LA. Here we are going to use some semiconductor device SCI, and this is the single diode model of the cell. Here I phase and I naught are the photovoltaic and saturation currents. Here Vt is k into number of series cells into temperature by q. Q means the electron charges equal to 1.6 the e power minus 19. We have to know this value already. And now if the array is compressed to number of parallels connections of the cell, PV saturation current may be expressed in IPV is equal to IPV into cells in number of parallel. Let equation 4 and equation 5 are the diode saturation currents. Here I face a equation. Here we have to describe the light generated current of PV cell depend on linearly on the solar radiation and is also influenced by the temperature according to the following equation. These following equation can be represented the photovoltaic current. Here T means actual temperature and TR is nominal temperature, and I we have to represent the watt per square meter is the irradiation on the device surface, and the IR is the nominal irradiation. Actually different solar parameters are considered here, like kc 200 gt solar array. In this rs and RSR we have to find these values for one MATLAB program, and that will be shown now. For finding RS and RSH, I have code like here in MATLAB. I'm going to show you this model. Here I'm giving that parameters like ISC and VOC, IMP and VMP, and KV and KI values. Now this is the MATLAB code for RS and RSH we have to find. Now I'm going to run this one. And this is the values what I'm getting. like RP is RP means R shunt 591.13 ohms, and RS is 0.2300. We have to see in here for RS and RP values. RSH, and here EG is the band gap energy of semiconductors. In SI we have to take 25 degrees of this semiconductor 1.12 EV, like that. Nominal saturation current also in equation 5 we have represented. Here VT is begin thermal voltage, and NS is the series connected cells of nominal temperature. And equation 7, this is the improved model of this diode current. And for these equations I'm going to do solar modeling, and this is my Simulink diagram of solar modeling. And now I'm going to show you in MATLAB. This is one type of Simulink model, and I'm going to show you another Simulink model in MATLAB. Here we go. First step by step we have to go to this one, and finally we have to connect. Now in this already I do this one, and I'm going to explain these equations. And I face this is the photocurrent, and next one is I naught is the saturation currents, and saturation current varies with the cell temperatures. Like that improved version I'm going to the equation I'm modified. And now with the ISH the current here RS is the resistance exists mainly due to the leakage current of PN junction, depends on the fabrication method of PV cells, and this RP value is RSH. This RSH value is generally high because the value of series is very low, and sometimes these parameters is neglected also. We have to shown in that MATLAB code. First we have to give an RS is 0, then we have to find that RS and RSH values by different using a Newton-Raphson method. Like that way we are doing in that MATLAB. And this is a single diode model, and we have to compare it with the double diode model. These single diode equations are assumes a constant value for the ideality factor. Like we have to take an ideality factor n is equal to 1.3, and in double diode model we have to take it in a different way. Like we have to use a is equal to 1, a2 is equal to 2, and some different equations are coming in now. At high voltage, when recombination of the device is dominant surface and bulk regions, the ideality factor is close to 1 in single double diode model. And these are the equations. And now I'm going to current I is equal to I phase minus ID minus ISH. And now I'm going to show you the model. Now I'm going to connect here SPSC to controlled current source, and here I'm using current sensors to PS converter because of current, and this is the electrical references we are using here, and the voltage sensor to Simulink converter. This is the value what I'm getting after simulate. Now I'm going to show this is the subsystem of the single diode model, and we have to do in there only, but different cells we have to do this one. Like that we have to add single another subsystem here and another here. We have to use seriously or parallelly. And now these pliers are connected to the current sensor to the current, and this one is the variable resistor. Here we are using that load is the variable resistor. This is the solver configuration, f of x is equal to 0 and electrical references. Now PS converters. Now this current into voltage is equal to power. These are the two graphs I am going to simulink now, and I have to run now. And these values are taken what I'm showing in that table. These are the PV graphs and IV graphs of my system. And here I am giving the current is 8.2. It is not going up to the level. And here I am giving voltage is 32.9. And here we have to see the display. It is not going up to the 39. And now to see is run Simulink, because we are using ramp. Ramp is controlling the variable resistor. And this is take some time. You have to be patient about this one. And any other queries, you have to comment me, and please subscribe my channel. Thank you guys. This is some more about a single diode model. Next I am going to explain double diode model in future. Thank you. And we have to show the last final Simulink here, then I have to close my video. Yes, because everyone is showing different aspects. You are not getting any answer. Please refer these equations and these Simulink. You get definitely right answer. Thank you once again. Thank you guys for listening patience to my model.